Good morning, viewers. Today we are going to take limits eamcet. Okay. My name is Yeshu. I have 7 years teaching experience in mathematics as an eamcet lecturer. So today limits. What is a limit? As x is approaches to a, f of x is approaches to L, where L is called the limit of the function, limit of a function f of x, and it can be written as limit extends to a, f of x is equal to a. See, what is that meaning? So x is approaches to a, this whatever the f of x is approaches to a, where L is called the limit of the function f of x, and it can be written as limit extends to f of x is equal to a. Here important thing is, we can take x value approaches to a means x, we can take this f of x, we can take this like a tabular form you take. From here I am going to explain you proper way. X you take 0.9. So what is the function f of x is equal to x plus 2. That means, according to limits point of view, limit extends to 2 x plus 2. See, here we take 1.9, and before extends to x is approaches to 2 means, so 1.99 before 2 value, 1.999, 1.49, like that is going on. 1.49. So this is the before the value x is approaches to 2, this value is not exactly equal to 2. Minor display value is missing in this, right? While substituting in the place of x, you substitute this means 1.9 plus 2, that is 3.9. 1.9 plus 3.99. This 3.9, right? 4. This is 4 actually. You can take stop here. 3.49, right? Why? We have whatever the input we are giving x value, the output will be 3.49. Because it is approaches to 4, but it is not equal to 4. While substituting 2 plus 2, that is 4 only. So that is the input value we are giving. X is approaches to 2. Approaches to the before values 1.9, 1.99, 1.999, like that. There's wherever the output value will become 3.9, 3.99, 3.999, 3.4, but it is not exactly equal to 4. Whatever the minute value is missing, that is called the limit. Okay, it's a limit is very interesting. That is mathematical point of view. This, okay. Limit extends to 3. Suppose, for example, we can take x cube minus 27 by x minus 3. How to do this? Whenever indeterminate forms are there, 0 by 0, we can check IDF, indeterminate forms. So what are the indeterminate? 0 to the power of 0, 1 to the power of infinity, and infinity minus infinity, infinity by infinity, and 0 by 0. These are all IDF forms whenever you go there. If you substitute in the place of 3, but it is only concept wise, but it is, while substituting you can substitute this 3 cube minus 27 by 3 minus 3. What is the answer? 27 by 27, 3 cancel, we will get 0 by 0, IDF. Whenever IDF will come, you go for LHS. That is the logic for this chapter. Okay? Logic means LHS. What is it mean by LHS? Whenever comes infinity by infinity, 0 by 0 will come, means here 0 by 0 cube. So we can directly differentiate the numerator. You can't go for u by u. Like you take limit extends to 3, x cube derivative is 3x square. Because n into x to the power of n minus 1 constant 0 by 1 minus 0, that becomes 3x square. In the place of x square, we can substitute 3. 3 square, 9 3 is 27. This is the answer. So this will be helpful for all the type of LHS, right? whenever limit how exists will be, suppose limit extends to 2 f of x is how to limit existence. Whenever is asking limit exist, the position of limit existence will be depends on limit extends to 2 minus f of x is equal to limit extends to 2 plus f of x. This 2 minus means left hand limit of 2. This means right hand limit. Whenever these two are equal, then a limit will be exist. Otherwise, it is does not exist. Okay? Whenever limit LHL left hand limit is equal to right hand limit, limit is exist. Otherwise, limit LHL is not equal to RHL, limit does not exist. Limit does not exist. So we can take limit exists, limit does not exist. Both are things. If it is equal, left hand limit is equal to right hand 2 minus 2 plus is equal, then it is limit exists. Otherwise, it is does not exist. 3 if you take, limit extends to 3 minus 3 plus. Both are equal, limit exists. Otherwise, it is does not exist. Apart from this, one more thing will be there. That is limit extends to a f of x whole to the power of g of x. This based on this, first in hospital way, you can go through the competitive levels. Next f of x whole to the power of g of x and 1 to the power of infinity form. 1 to the power of infinity form. So how it is 1 to the power of infinity? You can take the example I am going to teach. Limit extends to 0 tan x by x whole to the power of 1 by x square. If it is a problem, will be like this. What is the answer for this? How to do this problem, right? Straight from doing what is the form? Limit extends to 0 tan x by x is 1 by 0 infinity. 1 to the power, this is 1 to the power of infinity form. In that, whenever you got this 1 to the power of infinity, limit extends to a f of x whole to the power of g of x will be what? This we can e to the power of limit extends to a g of x into f of x minus 1. You can apply this formula. And whenever this is in infinity, 1 to the power of infinity or 0 to the power of 0, then only you can apply this. Limit extends to f of x whole to the power of g of x form is there. We can convert it into e to the power of limit extends to a g of x into f of x minus 1. How to do this? Right? We can do one thing. So we can substitute this. So e to the power of limit extends to a g of x. What is the g of x here? X. G of x. This is f of x. Tan x by x is f of x. The whole power. This is g of x. G of x into e to the power of limit extends to g. G of x into f of x. F of x means tan x by x minus 1. So like e to the power of limit extends to 0. We can do one thing. We can take the LCM tan x minus x by. If you multiply this means x cube. Now you can apply the last part rule. Why? Because if you substitute means 0 by 0 will do. And 0, 0, 0 minus 0 by 0 cube. So that in that case you can go for last part e to the power of limit extends to 0. Tan x is secant square x differentiation minus 1 by 3x square. So secant square x minus 1 what? Secant square x minus tan square x is 1. Secant square x minus 1 is tan square x minus 1. So e to the power of limit extends to 0. Take 1 by 3 out. Tan square x by x square. In according to the limits taken already we know in IP tan x by limit extends to 0 tan x by x is 1. But actually we can take s is equal to x sin x except tan x cosecant x wherever the cot x these values will consider as x. It's not a problem with x value. So x by x square by x square we can. It's in a particular point of vision of IP level standard limited. Instead of that, this is a way easy. X square by x square you can do. This cancel will get e to the power 1 by 3 results. So whenever you are having that 1 to the power of infinity or 0 to the power of 0, then only you can apply this form. That's the better. One more problem we are going to take. If it is infinity also, limit extends to infinity. Limit extends to infinity. X plus 6 by x plus 4 whole to the power of limit extends to infinity x plus 6 by x plus 4 x to the power of 4. This is which form? X by x, coefficient of x 1 to the power of infinity plus 1, infinity form. Because if it is infinity, coefficient of x in the numerator by coefficient of x in the denominator. That case is there. If it is coefficient of x square, because degree of x square, degree of x is more than the degree of x in the denominator, then should be 0. If degree of x is less than the degree of x in denominator, that value is infinity. So that we can take, if it is equal, degree of x in the numerator by degree, that is we can take directly 1. 1 to the power of, you can substitute here infinity plus 4 infinity over infinity. In the standard you take e to the power of limit x, same like this formula, e to the power of limit x tends to infinity, g of x into f of x minus 1, x plus 4 into x plus 6 by x plus 4 minus 1. So take the LCM, e to the power of limit x tends to infinity, take LCM, x to the power of 4 into x plus 6 minus x minus 4 by x plus 4. This, so that what, 6 minus 4, 2. E to the power of limit x plus 4 cancel, e to the power of 3. So e square is the answer. This is the one of the way to go for these easy shortcuts. Definitely will come in eamcet examination. That is very, very helpful. Okay. So apart from that, I am going to explain to you this. Suppose limit extends to 0. Limit extends to 0. This will be 4 to the power of x plus 16 to the power of x by 2 whole to the power of 1 by x. If it is problem is like this, if two terms are there, we can take square root of a.